In this video, we'll be covering velocity, collisions, explosions, and gravitational potential energy. Basic velocity is speed in a given direction. Speed is distance divided by time. This car is moving 200 meters in 11.1 seconds, so its total velocity is 18.018018 recurring meters per second. Momentum is mass times velocity. Now I will demonstrate a collision where both objects, in this case cars, are moving in the same direction. The total momentum before the collision will equal the total momentum after the collision. The mass of Ethan's car is 1,000 kilograms. The mass of my car, the one in front, is 1,200 kilograms. The velocity of Ethan's car is 30 meters per second, and the velocity of mine is 20 meters per second. We multiply the mass by the velocity to get the momentum. So Ethan's car has a momentum of 30,000 kilogram meters per second, and my car has a momentum of 24,000 kilogram meters per second. We add these together to get a total momentum before the collision of 54,000 kilogram meters per second. We add the individual masses together for a total of 2,200 kilograms. Then we divide the total momentum by the total mass to get 24.5454. This is the velocity after the collision in meters per second. Now here's a head-on collision. Again, the total momentum before the collision will equal the total momentum after the collision. In this case, Ethan's car has a mass of 1,600 kilograms and a velocity of 25 meters per second. My car has a mass of 1,200 kilograms and a velocity of negative 30 meters per second. The velocity of my car is negative because, as we said before, velocity is speed in a given direction, and my car is traveling in the opposite direction to Ethan's. As we did before, we'll multiply the mass by the velocity to get the momentum. So Ethan's car has a momentum of 40,000 and mine has a momentum of negative 36,000. Remember, the unit for these two is kilogram meters per second. Now I'll add the momentums together to get a combined total of 4,000 kilogram meters per second. Finally, we divide the total momentum by the total mass to get 1.4 meters per second. This is the total velocity after the collision. Now we'll apply conservation of momentum to explosions. Our example will be a gun firing. The explosion in this case is caused by pulling the trigger. Before the gun is fired, there is a total momentum of 0 kilogram meters per second, because both the gun and the bullet have no velocity. In other words, the velocities are 0 meters per second. The mass of the gun is 15 kilograms, and the mass of the bullet is 0.3 kilograms. However, there is a total momentum of 0 kilogram meters per second for both objects. After the gun is fired, using the same method we've used previously, we can work out the total velocity after the explosion. The masses of the gun and bullet of course remain the same, but now we know the bullet has a velocity of 900 meters per second, meaning we can calculate the total momentum of the bullet as 270 kilogram meters per second. We'll use this information to work out the velocity of the gun itself. For now, we'll label the velocity of the gun as v, meaning the momentum is 15v. We can now put the information we have into an equation. Because of conservation of momentum, we know that 15v plus 270 must be equal to 0. So our equation is 15v plus 270 equals 0. From there, if we take 270 from both sides, we get 15v equals negative 270. Then if we divide both sides by 15, we get a velocity of negative 18 meters per second. This is the recoil of the gun. Again, it is negative because the gun moves in the opposite direction of the bullet. The final concept that we're going to cover is gravitational potential. To work out gravitational potential, we do mass, which for the bathtub is 100 kilograms, times height, times gravitational field strength, which on Earth is 10 newtons per kilogram. The first height we're using is 2 meters, so the resulting gravitational potential energy will be 2 kilojoules. This next height is 4 meters, so the resulting energy is 4 kilojoules. Now we're using 6 meters, giving 6 kilojoules. This one is 8 meters, giving 8 kilojoules. And this final one is 10 meters, resulting in 10 kilojoules of gravitational potential energy. Finally, we're going to drop a caravan on David from a height of 100 meters. The caravan has a mass of 3,250 kilos, so the resulting gravitational potential energy will be 3,250 kilojoules.